In the last two videos, you learned how to use the request module to make an HTTP request for some information. In our case, the URL we requested was a Google Maps geocoding URL, and we passed in the address we want the latitude and the longitude for. Then we used a callback function which got fired once that data came back. Now, the goal in that video was not to understand how HTTP works or what exactly these arguments, error, response, and body are. The goal was to come up with a real-world example of a callback, as opposed to the contrived examples that we've been using so far with set timeout. In our case, we had a real callback that got fired once the HTTP request came back from the Google servers. We were able to print the body, and we saw exactly what we had over in the website. In this video, we're going to dive into those arguments, so let's kick things off by taking a look at the body. This is the third argument that request passes to the callback. And now the body is not something unique to the request module. Body is part of HTTP, which stands for the Hypertext Transfer Protocol. When you make a request to a website, the data that comes back, that is the body of the request. And you've actually used the body about 1 million times in your life. Every single time you request a URL in the browser, what you get rendered inside of the screen, that is the body. In the case of npmjs.com, the body that comes back is an HTML web page that the browser knows how to render. The body could also be some JSON information, which is the case in our Google API request. Either way, the body is the core data that comes back from the server. In our case, the body stores all of the location information we need, and we're going to be using that to pull out the formatted address, the latitude, and the longitude in just a second. Before we go ahead and dive into the body, I want to talk about the response object. We can go ahead and look at it by printing it to the screen. I'm going to swap out body in the console log statement for response. Then I'm going to save the file and rerun things over inside of the terminal by running node app.js. We're going to get that little delay while we wait for the request to come back, and then we get a really complex object. If you scroll up to the top, where we originally made the request, you can see the first thing we have in the response object is a status code. The status code is something that comes back from an HTTP request. It's part of the response, and it tells you exactly how the request went. In this case, a 200 means everything went great. And you're probably familiar with some status codes like 404, which means the page was not found, or 500, which means the server crashed. Now, there are other body codes we'll be using throughout the course. Like I mentioned, we're going to be making our very own HTTP API, so you'll become intimately familiar with how to set and use status codes. For now, all we care about is that the status code is a 200. That means things went well. Next up in the response object, we actually have the body repeated because it is part of the response. Since it's the most useful piece of information that comes back, the request module developers chose to make it the third argument, although you could access it using response.body, as you can clearly see here. In here, we have all of the information we've already looked at, address components, formatted address, geometry, so on and so forth. Down below body, we have something called headers. Now, headers are part of the HTTP protocol. They are key value pairs, as you can see here, where the key and the value are both strings. They can be sent in the request, that's from the Node server to the Google API server, and in the response, from the Google API server back to the Node server. Headers are fantastic. There's a lot of built-in ones like content type. The content type is HTML for a website, and in our case, it's application/JSON. We'll talk about headers more in the future. Most of these headers are not important to our application, and most we're never ever going to use. When we go on and create our own API later in the course, you'll be setting your own headers, so you'll be intimately familiar with how these headers work. For now, we can ignore them completely. All I want you to know is that the headers you see here, these are headers set by Google. They're headers that come back from their servers. Down below headers, we have the request object. This stores some information about the request that was made. Here you can see the protocol, HTTPS, the host, the googleapis.com website, and all sorts of other things like the address parameters, the entire URL. Everything about the request is stored right here. Down below, we also have our own headers. These are headers that were sent from Node to the Google API. Now you're probably wondering how this even got set. Well, this header got set when we added JSON true to the options object. We told request we want JSON back, and request went on to tell Google, hey, we want to accept some JSON data back. So if you can work with that format, go ahead and send it back. And that's exactly what Google did. This is the response object. It stores information about the response and about the request. While we're not going to be using most of the things inside of the response argument, it is important to know they exist. So if you ever need to access them, you know where they live. We'll be using some of this information throughout the course, but as I mentioned, most of it is not necessary. For the most part, we're going to be accessing the body. One thing we are going to be using is the thing at the very top, that status. In our case, it was 200. This is going to be important when we're making sure that the request was fulfilled successfully. If we can't fetch the location, if we get an error in the status code, we do not want to go on to try to fetch the weather, because obviously we don't have the latitude and longitude information. We're not going to worry about the status code errors yet. That is going to come up soon. For now, we can move on to the final thing, which is error. Now, as I just mentioned, the status code can reveal that an error occurred, but this is going to be an error on the Google servers. Maybe the Google servers have a syntax error and their program is crashing. Maybe the data that you sent is invalid. For example, you sent an address that doesn't exist. Those errors are going to become evident via the status code. What the error argument contains is errors related to the process of even making that HTTP request. For example, maybe the domain is wrong. If I delete S and the dot with GO, I get a URL that most likely doesn't exist. In this case, I'm going to get an error in the error object because Node cannot make the HTTP request. It can't even connect to the server. I could also get an error right here if the machine I'm making the request from does not have access to the internet. It's going to try to reach out to the Google servers. That is going to fail, and we're going to get an error. Now we can check out the error object by deleting those pieces of text from the URL and making a request. In this case, I'm going to swap out response for error. Awesome. Now, over inside of the terminal, I can scroll to the bottom, rerun the application by running node app.js, and we can see exactly what we get back. When I make the bad request, we get our error object printing to the screen. And the thing we really care about is the error code. In this case, we have the e-not-found error, and this means that our local machine could not connect to the host provided. In this case, map.ooglesapi.com, it doesn't exist, so we're getting an error right here. These are going to be those system errors I talked about, things like your program not being able to connect to the internet or the domain not being found. This is also going to be really important when it comes to creating some error handling for our application. There is a chance that the user's machine won't be connected to the internet, and we're going to want to make sure to take the appropriate actions, and we'll do that depending on what is inside of the error object. For now, though, we can fix the URL, setting it back to maps.googleapis.com. Now, if we make the exact same request by using the up arrow key and the enter key, the request error object, it's going to be empty. Here you can see null prints to the screen. In this case, everything went great. There was no error. It was able to successfully fetch the data, which it should because we have a valid URL. That is a quick rundown of the body, the response, and the error argument. We are going to be using them in more detail as we add error handling. I wanted to give you a quick overview of exactly what is inside of each. To wrap this video up, we're going to print some data from the body to the screen. I'm going to get started by printing the formatted address, and you are going to be responsible for printing both the latitude and the longitude. In order to figure out exactly where formatted address is, I'm going to go to the browser and use JSON View. One of the reasons I love JSON View is it makes it easy to see where inside of the response that data you have highlighted lives. At the bottom, you can see that little blue bar shows up when I highlight over items, and it changes as I switch items. For formatted address, for example, we access the results property. Results is an array. In the case of most addresses, you're only going to get one result. We're going to use the first result every time. So we have the index of 0, then it's the .formatted_address property. That is exactly what we need to type over inside of our node code. Back inside of Atom, I'm going to delete this line and replace it with a new console.log statement, console.log, and I'm going to use template strings to add some nice formatting to this. I'm going to say address with a colon and a space. Then I'm going to inject the address using the $sign and the curly braces. We're going to access the body. Then we're going to access results. Then we're going to access the first item in the results array, followed by formatted address. .formatted_address. address. With this in place, I can now add a semicolon at the end and save the file. Over inside of the terminal, I can rerun the application. And this time around, we get our address printing to the screen. 301 Lombard Street, Philadelphia, PA, 19147 in the USA. Now that we have the address printing to the screen, what I would like you to do is print both the latitude and the longitude. Now there are a few variations of that. There's the bounds, the northeast and the southwest bounds. We don't care about that. What we want is this location properties, latitude and longitude. That means you're going to go into geometry, you're going to go into location, and you're going to grab those two props. Use two console.log statements, one for latitude and one for longitude, printing both to the screen. When you're done, go ahead and rerun the app from the terminal. Make sure you see the formatted address and make sure you get the right latitude and longitude printing to the terminal. If you do, then you are done the challenge and you can go ahead and click play. Take a moment, pause the video, knock that one out and click play. How'd you do? Hopefully you were able to print both the latitude and longitude to the screen. In order to get started, over inside of Atom, I'm going to add another console.log line right below. Console.log, and I'm going to use template strings once again to add some nice formatting. Let's print the latitude first. Latitude, followed by a colon. Then I can inject my variable using the $sign with the curly braces, and in this case, the variable we want is on the body. It's also in that first results item, results at the index of 0. This time, we're not going to be going into formatted address, we're going to be going into geometry. From geometry, we're going to grab the location prop, and in there is the latitude, .lat. Awesome. Now that we have this in place, we can do the exact same thing for longitude. I'm going to add another console.log line right below, console.log. I'm going to use template strings once again, typing longitude first. After that, we're going to put a colon and then we'll inject the value. In this case, the value is on the body. It's in that same results item, the first one. We're going to go into geometry location again. Instead of lat, we're going to access .lng. Then we can go ahead and add a semicolon at the end and save the file. Now that we're done updating the app.js part of the challenge, we can finish up by testing it from the terminal. I'm going to rerun the previous command. And right here, you can see we have the latitude, 39.94, and the longitude, minus 75.16 printing to the screen. And these are the exact same values we have over inside of the Chrome browser, 39.94 minus 75.16. With this in place, we've now successfully pulled off the data we need to make that request to the Weather API. In the next video, we're going to go ahead and add some error handling to this callback because that's going to be really important for our HTTP requests. There's a chance that things go wrong, and when they do, inside of the callback, we're going to want to handle that error by printing a nice error message to the screen. So stay tuned. I am super excited to continue building the weather application. I will see you next time.